Hey there, welcome back to Farmcraft. I'm John, and in the last video I had a lot of trouble getting these track pins out. I ended up cobbling together a makeshift pin press using a 50-ton bottle jack, which worked quite well actually. But it was welded together and would have to be cut apart and re-welded for each use. So in this video I'm going to go on and build a proper 50-ton pin press for less than 300 bucks. I've got lots of machining to do, quite a bit more than I was expecting of course, so let's get to work. I've already disassembled the welded one. But rather than using those half-inch plates, which were bending, we're a little bent. From a friend, I got this 1-inch plate, a 14-inch circle. So you can see when I set the jack on there, I've got room around it to drill holes, and I'm going to use some 1-inch threaded rod to be able to put it together. And then you can adjust the length and everything that you need with the threaded rod. If I have a different configuration in the future, I could maybe drill some other holes in different areas. Maybe even use a 20-ton jack for a smaller machine. So hopefully this will be a nice flexible addition in the future. Now these pieces of 1-inch plate are pretty rough. They're flame cut, pretty rusty. That's just fine, that'll work fine, but my OCD can't take it. Plus I'm still waiting on the seals anyway, so let's make this into a proper tool. I'm going to start out drilling a 1-inch hole right in the center. This is the same center mark that was used when the plates were cut out. Alright, so I actually need a 2-inch hole in the center of these, and that's so that I have room to push a pin through. The pins on large marge are 1 3/4 inches. I actually have a 2-inch bit, but this shank will not fit in that drill, and I don't think the drill could run it anyway. That's a heck of a bit. So now that I have a 1-inch hole and they're both on center, I can use a pin to align them, and I can go ahead and drill the tripod holes for where the threaded rods are going to go. And then I hope I'm going to be able to use those holes to mount this on the lathe. Bore that out to 2 inches, true the outside, clean everything up. That's the plan. We'll see how it goes. So I've got it marked where I want these holes. Of course I want them lined up on the 2 plates so they'll be perfectly parallel. So here's a 1-inch rod. So now on center, these plates are aligned. So I just need to clamp them. So now, if I drill through one, it'll mark the one underneath. So I can go ahead and drill the top, and then I will know exactly where the holes for the bottom should be, and then I can drill those as well. Alright, so this is the faceplate for my lathe, and unfortunately those holes are not going to help me bolt to that, and I figured that was going to happen. The good news is this is 1-inch plate. I can have tons of holes in this thing. It's only going to make it lighter. It's going to be plenty strong, so I can just drill 3 holes to allow me to mount this To be fair, all of this is really not necessary. I just kind of want to do some machining, and I think it would be cool to have this come out as an actual tool rather than kind of a cobbled together scrap thing. So I need a way to get this as centered as I can. I mean, it doesn't have to be absolutely perfect, but better than eyeballing it. Well, I know that's a 1-inch hole on the plate, and this actually measures 2.36, probably a metric measurement, but I can turn something down to that. And in fact, I've got a piece of scrap right here, so I'm going to turn one side down to 2.36, the other side down to 1 inch, and I can put that in there and register that faceplate exactly in the center, and then I will mark and drill some holes. If that didn't make sense, it will in a second. Alright, so that should fit in there. It had me worried for a second, but it does. And this should go over it. So now that keeps it centered. I am going to drill and tap for these M12 bolts. I've had decent luck in the past of eyeballing a tap vertically like this, but the thicker the material, the more important it is that you're exactly straight up and down. If you're off by a little bit, when you get to the bottom of that hole, since it's 1 inch thick, you're really taking a lot of material out of one side with your tap. And I was pushing so hard on this thing, I was worried I was going to break the tap off. Alright, that one got a little hard to get through at the end, and I think it's because I wasn't perfectly straight up and down. It's always best to tap with the drill that you drilled the hole with. The reason I didn't is because that mag drill doesn't give you enough room. I mean, you can do it with like a wrench, but it's just not, you can't use a tap wrench. I think for these next ones, I'm going to make something that's going to help keep me perfectly straight up and down as I'm starting the thread. So this piece of aluminum, I just drilled it out on the mill so that it just clears the tap, but will keep the tap perpendicular like that. I think that's going to do the trick. Once you have that started, you don't need to worry about it. This one went a lot better. Alright, one more to do, and then I need to do the other plate as well. I'll do the same thing and then bring you back. Now I'm ready to actually mount this plate on the face plate so that we can turn it on the lathe. That's not going anywhere. Uh-oh. Yeah, I actually knew that was going to happen. And I really put some thought to this on, do I really want to do this before I started this job? So this is a 12 by 36 lathe, which means the center line to the ways is 6 inches, so you can turn something that's 12 inches. This is just over 14 inches, so it's not going to go on there. But this has a gap bed in it. This piece right here to that line there, and you can see there's a line there, goes across the ways. You can't feel it, but it's there. That whole thing lifts out and allows you to turn up to 17 inches to this point at least. Now, that's what your carriage is riding on, so it does limit what you can do. So basically, you can do the kind of work that I'm doing on this job exactly, faceplate work, up to 17-inch diameter, which that's plenty. The only issue is, on a high-quality lathe, you pop this thing out, you have to keep everything really clean, make sure there's no chips, you put it back in, you roll on. On a lower quality lathe, that's not always the case. Now, this is a Grizzly lathe. I've been very impressed with it thus far. Everything has been quite accurate and machined to good quality standards, in my opinion. But they put this bed in here, and then they grind this. So when you take the gap bed out, putting it back in, there's no guarantee that you're going to be able to get that to a line again. And before I take it out, I'm going to do a little bit of checking with a dial indicator to kind of see where we are. Like this line here, I can't feel that one. This one here, I can feel the tiniest bit. It looks like it's higher on the bed than it is on the rest of the lathe. Alright, that's right on 0. Well, it moved, yeah, about 1/2 thousandth. Right there. Yeah, that's just 1/2 thou. I don't see any movement at all on that one. So that one is dead on. This one is 1/2 thou high. And I've already done a straight edge along it. It's perfectly in line this way and this way. This is what the lathe's for. This is why you have a gap bed. You should be able to take it out and put it back in. I hope I'm not going to regret it, but I'll pull it out. We'll do this job at the end of the video. I'm going to put it back in and we'll see how it goes. It's tight. That bolt right there is pushing against that and pushing the gap bed against these ways here. And I'm going to have to modify an Allen wrench to get in there. It just needs to be shorter there. Alright, so these are dowel pins, and if you tighten those nuts, the pin should pull out. Interesting. Okay. There should be nothing holding this in. There it goes. So it looks like there was some sealant or something here. They did paint this, so maybe they just, after assembling it, they squirted some sealant in there so that the paint and everything wouldn't get up inside, protect it from water or whatever. I don't know. Wow. Check this out. People who know about machines know what they're looking at there. That interesting crosshatch pattern, that is scraping to make that perfectly flat. So they did a really good job with this. That really gives me confidence that I'm going to be able to put this thing back together and it's going to be dead on. Very cool. Good job, Grizzly. Ow. I figured this might be an issue, but it's worse than I expected. I think I'm going to have to figure out a way to pull that plate further out so that it's closer to my tool post, because I'm right at the end of my ways here. I mean, I can go a little further, but I'm losing support when I do that. And this bar is, I mean, that's sticking out 5 inches. With this little tool post, this lathe is not that heavy. I don't know if it's going to be able to take that. And I have a lot of turning to do on this OD. Let me give it a touch and just see what it does, but I think there's going to be way too much flex here. I've done basically nothing. Where have I even hit it? If I can't even see where I'm hitting it. I'm just too far away here, so I'm going to do a couple things. Now, I was trying to cut this with high-speed steel. It's sticking out way too much, and this bar is not big enough. It's not stiff enough. But high-speed steel on cutting this flame cut, the flame cut stuff gets hard, and it's kind of at a disadvantage there, so I don't think that's going to work. I do think my carbide can cut it, but my boring bars are set up to go this way, not this way. But if I put the boring bar upside down, so now the cutting edge is there, and I rotate the opposite direction, I spin the lathe backwards, I can now cut on this face with the boring bar. I don't have the option to go to this face because I'd have to move the cross slide all the way. It won't go that far. So I'm going to end up turning it with the boring bar upside down, but I still have too much stick out here. So I am going to space the plate that I'm machining 2 inches out with this aluminum hub that's nicely machined, so it's got parallel sides. It is a little too big for the bolts, so I'm going to need to make some notches in it there. There, that'll work for that. I don't have bolts long enough. These ones that go from the faceplate to there obviously aren't going to reach when I add 2 inches, and I don't have any others. So I'm going to need to machine those, and in order to do that I need my lathe. So the gap beds left me far away from this as well. You definitely need some long tooling if you're doing gap bed turning, unless I'm missing something here. I'm going to do it backwards again and use the boring bar and just spin it this way. Kind of jacked up those threads there. 3/4 of an inch of good threads, and then like a 1/4 inch bad, and then they're good again. I think it'll work. I need to make 2 more of those. It's pretty well centered. So this is 220 RPM. Go this way. Ah! It just broke, but it was getting dull anyway, so I'm going to flip that around to a new cutting edge. All right, let's roll. Did you see that? It actually pushed the boring bar away from the cut. You'll see that more in some sped up footage coming up here. So the bar is being pushed away because it's shifting in the tool holder, and that's something that's not actually as obvious when you're there as it is on camera. So I've been sitting here trying to turn this for a while, and it's just not cutting it. I think this is too hard, and with this setup especially, all the spring that I have in it, the interrupted cut, and then this being flame cut, I think I'm going to have to do another step that I didn't really want to do. Really, I need a bigger boring bar. Let me see if I can just face it off. That would be really nice, actually. Well, it's safe to say this thing is not machining like I was hoping. It's frustrating too, because if I could get close to it, have a tool with just, you know, like an inch of stick out, I could face that off. This lathe is stiff enough to do that. But sticking out here, you know, 4.5 inches probably, it just can't. It's actually starting to look good. Well, this is the first time I've ever felt like my lathe might not be big enough for the job. And that doesn't surprise me. I'm working with 1-inch material, 14 inches in diameter. I've got a brand new cutting edge on there, and I'm going to try to face this off at least out to there. Come on. Well, that's actually cutting. Well, that's more what I had in mind. I think I can actually finish that face off if I rotate this around. And then I'm just going to have to finish this flame cut stuff with abrasives because I don't have anything that's going to cut that, certainly not with this setup. That's as far out as I can reach with the compound on my lathe. It's almost like I need a bigger one. That's real progress. Now, I need to be able to turn out a little bit further, and I'm going to have to deal with this hardened flame cut area. I plan to do that with abrasives, probably exclusively, or maybe I'll do a lot with abrasives and then I'll be able to put it back on the lathe. After I do my lathe modification, make myself a different compound that will just be for this purpose. It will extend out here, it'll have some support even under this part of the carriage, and get me close to the work where I want to be. It's going to be a one piece. It's not going to have any play in the compound, and it's going to be much heavier. Let me get to work on that. And I know some of you are thinking you're wasting your time here, and yeah, that's true. I can definitely use this. You'll see when I'm done that surfacing this and making it pretty is certainly not necessary. It could definitely work, but I would much rather have this as a nicer tool to use in the future, and I'm learning about my lathe and its capabilities and doing some improvements on it. So this isn't just about getting this job done. This is also about learning some new stuff on the lathe, because turning faceplates and stuff like this is definitely something I come across time to time. Here's my plan for the compound. Now this thing rotates here. You tighten the nuts down there to lock it in place. And obviously you turn the crank and it goes in and out. I'm just going to have a solid compound here, but it's going to be longer. It's also going to be beefier. This round part is not going to be here. It's going to be right down there on the cross slide, bolted down the same way. And I'm going to have it sticking out an extra 3 inches. If we take our tool post off, you can see how that works. This is basically just a bolt, and you crank a nut down on there, and that locks the tool post in position. So this is going to be 3 inches closer. I'm also going to extend the back. I could take a big clamp between here and here, and I could clamp it down, and that would give me additional support out here. Then under here, I'm thinking I'm going to have some sort of wedge that I can adjust with a screw so that I can wedge it against this. And again, that would make it so that I couldn't cross slide, but when I'm out here trying to turn where I'm reaching furthest, I would be able to wedge that in position, clamp this down. So now I'm supported in the center, I'm supported here, I'm supported back here, and I can move the carriage in and out. Hopefully I won't be doing so much turning where I need all this extra support. Hopefully just the solid compound sticking out further would be enough. So you can see basically these are actually regular bolts they have in here. And then there's a center stud that I'm going to need to go down over. So my overall length will be 13.5 inches. This is probably going to take a while. Well, that was a lot faster than I was expecting. I do like that saw. Here I'm finding the center of the part. Using this edge finder, I can locate exactly where this edge is and then go to the other side and locate that edge, measure the distance between, cut it in half, and then I'll be directly on center. And now I can start drilling for that center stud that this needs to fit over. Here I'm using an end mill to flatten the bottom of the hole. So that's an inch, but of course it's actually 26 millimeters. I don't have a 26 millimeter drill bit or end mill, so we're going to bore it out. Yeah, so that's 1 in 15 thousandths. I need 1 in 23, so 8 more. Get it out of there and see if it fits. It should fit. Oh yeah. You can see that my bolt is right up against the face. There's not going to be room for a washer and a nut there. And obviously I don't have anything that the bolt's actually going through. So what I think I'm going to do, we'll go like from here to here. We are going to weld on a plate. Then I will take an end mill down. We'll cut out a round section there down to where the nut and washer need to be so that I'll be able to screw it down. So basically there's going to be a little wing of 1/2 inch steel welded on here and on the opposite side, which is exactly like this. Well, I just ran a dial indicator down it, and this thing is banana shaped, so I guess I'm going to need to flatten it. I was hoping it would be flat enough, but you can see there I'm basically on 0. Y direction if you stay. Nope. Yeah, I'm going to have to flatten that. So after you mill something like that, you can see where the cutting head was, but you can't feel it. That thing is nice and flat now. You may have noticed these are tilted up a little bit from welding. It doesn't matter, the bolt is going to be like right there, and that's just there to really support the bolt head. It'll be fine. I need to leave room for a socket to get down on it. So I'm going to use this washer to give me a little clearance, Clarence. Alright, so now I need to mill that down to the plate and leave a flat for the washer to sit against. May not have been necessary, but I went ahead and built up a support over here and finished it off with some shim stock to get the exact right height. So that's well supported. They make machinist jacks for that kind of thing. I don't have any, need to get some. Okay, so all I'm going to be doing here is basically eyeballing to get it to cut at least to that line, so I have enough clearance. And then I'm going to take it all the way down until I get a flat all the way across. And then we'll do the same thing on the other side. Pretty simple at this point. It wasn't real happy cutting like this. I have a couple options. I could take smaller bites. But I decided to just go down it with a smaller roughing end mill to kind of hog out the center. This cut very well. So back to the larger end mill, which seemed to be much happier, at least for a little while. So you probably saw there that the whole vise moved. I didn't realize that until I actually went to editing this. Well, that didn't sound happy. I thought it had just started chattering a bit, and I was going to slow down my feed rate to take some of the pressure off. When I restarted, it seemed like it was cutting really well. Well, it happens. Alright, so the other way to do this would have been to just take progressively deeper cuts and work your way in. And I thought about doing that. I thought I could do it this way, though. It didn't seem like an unreasonable way to do it. And now here we are. I'm curious if it scrapped that end mill. Surprisingly, it's not bent. Messed up right on the bottom there. So you can come in from the side, but you're not going to be able to come down like I was doing very well. Man. So it rotated. You know, this mill is designed to be able to rotate here. I have not moved that in forever. I wonder how tight those bolts are. Did they work loose? There's 3 nuts on this thing, and one of them is right there. Right there. Let's see if it's tight. It's pretty tight. And I guess it could have been a little tighter. One more is underneath here. That one was also pretty tight. And the last one is right here. So I feel like all 3 of them were pretty tight, but could have been a little tighter. So I'm going to tram this thing, and so here's the quill, and my dial indicator is on the vise or the table, and I'm going to move it up and down until there's no movement on the dial indicator. to get it perfectly vertical relative to the table. You can see that the indicator is going that way, so that means the whole thing needs to twist like this. Now I'm on 1, so it needs to go back a hair. So I got it dead on, but often things will move when you're tightening it down. Alright, this wasn't as bad as I thought it would be. It pretty much stayed vertical. I've got them all good and tight now. Good and tight. And we are going to do the full length of the quill, which is 5 inches. And we're starting at 1 on the dial indicator. And we're still on 1. So I think that's close enough. If there is any good news to be had here, I didn't scrap the part. I mean, it's ugly. I could potentially mill this out and then take that face off and make it all look pretty, but I don't care about that. This just needs to be strong. At this point, I think, most likely, I'm just going to roll on with it. The problem is, it messed up my end mill. That's the only end mill of that size that I have. So I'm going to have to figure out what I'm going to do here. This whole part here is chipped off. And then on the other side, it's just the very tip. Just the tip, and only for a second, but should be able to sharpen that. I carefully measured the angles that were on it, and I ended up sharpening it by hand on the belt grinder, using blocks of wood to try to maintain the same angles. It sort of worked, but nothing to write home about. Hopefully it'll be good enough to finish out this project. So I should mention, I also noticed that the vise moved. It twisted. That probably saved the cutter. I was wondering how it was able to hit out here without being totally bent. So I trammed the vise. I also, when I mounted this back, I put a hold down on it so that everything's more rigid now. We're going to come all the way down to here, and then I'm going to slowly work my way in, making sure I don't put a lot of cutting pressure on it. I hope we're not going to do that again. I have to say, that cut a lot better than I was expecting it to. All right, one more pass. And then this end mill is probably done for, unless I can get it professionally sharpened. So there's my nice apprentice mark. But you know what's funny? This is the side that's toward the headstock, and that means that it's going to sit on there like this, and that whole fiasco over there is going to be invisible. What I need to do next, though, is drill these holes. I'm going to flip it over and just get them in the right place and drill them from the bottom. Like that. Now, if I measured right, which is always a big if, I should be able to drop this thing down on here. Hey, look at that. They did the exact same thing I'm going to do, I can see. They surfaced the top right here. They didn't worry about this because this doesn't matter. So that's exactly what I'm going to do. I'm going to flatten this, make it parallel with the underside that we've already flattened. I'm going to mill in this groove, and then we're going to come back and mill in the T-slots. I'm still waiting for the T-slot cutter that I ordered, but hopefully it's going to get here today or tomorrow. It doesn't look great, it feels fine. That's much flatter than it probably looks like on camera. So this doesn't have to be that perfect. I'm eyeballing this side of the cutter to the face. So I'm going to zero that on my digital readout. I come over 863 thousandths. That is basically that. Will be right there. I'm going to zero my X again. What I'm going to do is touch off. There. So now I've zeroed that. So now I need to make a groove that is 520 thousandths deep. I'll probably just go 50 thousandths a cut. I think it'll handle that okay. I'm using this anchor lube because it doesn't fill up my shop with that noxious smoke. When I do a lot of machining, the cutting oil makes so much smoke it kind of gets overwhelming. So that's full depth. The entire width of it is 1.263 inches. So basically from here to the far edge is 1.263, but that is a 5/8 cutter, which comes out to 625. So when you do the math, you get 0.638. So I need to move over 0.638 from here to get my groove. I think I'm going to side mill it. I'll just keep the depth like it is, and I'm going to inch over 50 thousandths at a time, do a cut, come back, do a cut, and just go back and forth that way. Yeah, it definitely feels like it can handle more than that. Yep, no problem. I'll just keep doing 100. We should be there. So now I just need a T-slot cutter to cut those slots. My cutter got here late last night, and this is a high-speed steel key seat cutter. So now I need to touch off on the bottom of that. There, I'm just touching so I can zero the digital readout and lock the quill. And we're moving over 100 thou. Alright, so back to zero. There, we're back on center line. And now 100. Oops. Need to come up 105 thousandths. Stupid thing. I did not come up 105 thousandths because this was on metric. I came up 1.05 millimeters. I was going to say that looked too small. When I say this thing, I'm talking about this digital readout that's on my quill. Thank goodness it wasn't wrong the other way. This should fit in there, and it does. Nice. There is a little bit of play with the bolt that goes in there, and I thought about tightening it up, but I decided, you know, this works fine. I've never had a complaint about it, that I would just keep it the same, because sometimes when I try to make things more snug, it'll end up being a problem. Like chips will get in there or who knows what. This has never caused me any grief, works great. So I did the exact same measurements on the new one. Something worth noticing here, even though this one's so much thicker than this, This has the dovetail and then this round piece underneath it, so it actually ends up taller. So my new one is lower, and I measured that. That's 300 thousandths actually exactly of an inch. So in order to keep my tool holders at the same height when I'm done, I'm just going to have to make a little shim that will hold them up 300 thousandths. We'll look at that later. So now you can see, even with a short tool holder like that, I can even reach that entire face there. So that's really nice. The other thing, because my swing is actually 17 inches, I don't think I would have been able to reach a 17-inch piece before. But with this being longer and I can rotate it out, I can turn something that has a larger diameter now and easily reach it. Now this is 300 thousandths lower than the other tool holder. Well, that tool holder, all of these are set up to cut right on center line, and that adjustment is made right here, and I don't want to have to readjust all the tools every time I come over to this. So what I need is a spacer that I can put right there that's 300 thousandths thick. So when you drop the tool on there, it'll hit that spacer right there, and it'll stop, you know, somewhere like here, and then that'll be right on center line with this holder as well. So now that tool is below center height by 300 thousandths. This measures 300 thousandths. So I just put it in between, tighten it up, and now we're on center height. So I'm going to put a little magnet here, and we'll just keep it there. And here you can see, if I were to put a block under here and then a clamp over here, I would have maximum rigidity, and I would still be able to move the carriage, which would allow me to do the outside turning on the piece. But for this project, because it's gotten hard from flame cutting, I'm going to use the belt grinder to do this. So I don't need this block right now. I'm not going to bother machining it, and we're going to move on with this project. I need to finish facing this off where I couldn't quite reach before. I'm into the hard stuff. I think most of that is going to come off on the belt grinder. My heavy duty tool holder worked great. I mean, it turned that like nothing. No chatter or anything. So I'm going to be a little smarter from here on out. The other side of this, I'm going to take the rust off with a grinder before I put it back on here to surface that side. But we're going to do this outer edge first. Get that round. I'll clean up the other side. We'll put this back on here and turn that. I found this fits perfectly in that bore, so I just need to clamp that down. Who would have thought I'd get a better surface finish on a grinder than with a lathe? So before I turn the other face, I want to take this rust off, and I discovered something. I don't know if you can see that. That explains a thing or two. A516 grade 70 steel. So this is a medium carbon steel. The carbon already being there, when you cut it with a torch, it's going to get hard. That would explain that. I usually use this for centering things, but it's not really big enough. I mean, I could get it close. It just so turns out that the keyless chuck on my tailstock goes from 1.9 inches up to like 2.4, and that's a 2-inch bore. So it will center it just fine. Yep, that'll do. Alright, now I'm hoping I can turn this thing in one pass, and we are going to use some auto feed. Well, that's quite a difference. That's what I had in mind. You can see different surface finishes as you go in, but you can't feel anything. And the reason for that is because your surface feet per minute is changing dramatically. It's going at 220 RPM, which is a lot of feet per minute here and not much at all there. So the only other thing I want to do is get a little chamfer on these corners. I would use the lathe, but it's not perfectly centered, and I don't feel like fooling with that. Yeah, I figured I would just file this off real quick, but it wasn't filing nearly as fast as I thought it would. Apparently there's still hard material on this outer edge. Well, if you doubted it was hard, it is leaving grooves in my file that I can feel. That stinks. So I used a ceramic abrasive belt from the belt grinder. That'll work. I still need to do the other plate, and I'm going to go ahead and grind the outer edge first. It doesn't have a 2-inch hole in it yet, just a 1-inch, so I'm using a 1-inch plug to hold it in place. And I'm using a new belt for this, so let's see how long this one takes. So with the new belt, this one took about 45 minutes, so it went faster. But this one didn't have as nice of a surface finish, and it also had one area that was cut a little close to the center, so I didn't get it perfectly round. I cleaned the rust off of it. Let's throw this thing on the lathe and face it off. So it's worth putting a dial indicator on it and making sure you take enough off to clean it up. Ooh, I see 15. Yeah, so I need to take off more than 15 to clean it. Still sounds interrupted. Let's see how it looks. Yeah, it needs just a little bit more. That was the limit of what my cross slide could do with my tool post out here angled away from the center, but that's going to get drilled out anyway. So I want to drill this out, but I'm not perfectly on center right now, so I'm going to use this boring bar to get it perfectly on center, because I'm going to be going up to that giant 2-inch drill. So against my better judgment, I'm going to try to chamfer this one with this carbide insert. cutting. Carbide's an amazing material. And I've got this thing running really true right now. I'm afraid when I turn it around to face the other side, it may not be running true. So let me see about chamfering that. How can I reach that? Look at that. That's gonna reach. You guys probably can't see that, but take my word for it. All right, don't take my word for it. I'll set up a camera. End plates are done. That didn't take very long. Only a few days of machining to get here. So for you skeptics out there who say that I'm wasting my time doing this, machining this isn't about making a pin press. It's more about learning the limits of my lathe, improving my lathe, and just figuring this stuff out, because the next time I'm doing this, it's probably going to be something more critical that I really need to be able to get right. And now I kind of know what the machine can do. That's my excuse, and I'm sticking to it. Okay, so the last thing I want to do to these before I'm ready to use them is put a finish on them. And this is something I've been wanting to try for a while. Rather than just painting them, which with the way these are going to be used, the paint would just get scraped right off wherever the metal on metal parts are. I want to try something that's considered to be tougher. This is a classic blacksmith finish, and it's to use linseed oil, but to heat the metal very hot. So the linseed oil, I think it polymerizes or something. It reacts with the steel. It'll turn it black, but it makes a rust-resistant finish. I imagine it can still rust. That's supposed to be tougher than paint, and will allow you to touch it without getting rust all over you and everything. Obviously, I could have used these things the way they were with just drilling a few holes in them. But then every time you pick it up, it's rusty. If you drop it in the grass or wherever you're working, it's just going to just be a big mess. If I can get a nice finish on this, I think this will be a lot more pleasant to use. So we're going to give this a try, and we'll see how it goes. I've never done this before. I would not want to do this to the tool post holder that we made, because I think heating it that much would warp it, and I want it to stay flat. I think that would be a problem. These don't strictly have to be flat, so if they warp a little bit, no big deal. All right, so the first thing I'm going to do is clean them up with some acetone. So this is to clean all the oil off the surface before I apply the finish. And I don't want to use brake cleaner here because I'm going to be heating this up quite hot. And when you heat up brake cleaner, it can actually make some pretty noxious chemicals. And I want to heat it up to about a purple. If you don't get it hot enough, it kind of makes an amber looking color that I don't particularly want. I'd rather it was black. So hotter equals black. Okay, so this is linseed oil. And That thing is pretty darn hot. So I'm going to let that one sit there. I'll start heating this one, do the same thing, and then I'm going to go back and do one more coat on that. All right, just finished the second one, and kind of interesting. There's kind of a reddish hue to it. I just want them to not rust, and I think this is going to do that. What I've read is this stuff is a tougher finish than paint. Hopefully it'll hold up better. We're going to find out. You know, it's not a perfectly even finish, but for the most part it just looks black to brown and occasionally amber. You know, it's nice and clean. It feels like it's sealed up. I think that's really gonna work for what I'm trying to do. Just keep those from rusting and be a tough finish that's not just gonna nick up so easily when I'm using it. I guess we'll see, but I'm pretty happy with that. All right, I am getting ready to put the gap bed back in. Cleaned up really well. There's no chips. I didn't do too much to it because I don't want to make it, you know, go scraping it and make it less accurate than it already is. I just cleaned up the areas where it's metal to metal, made sure there's no chips there, made sure there was no like loose sealant or anything that would hang it up. And we're going to put it back together and put a dial indicator on it. Now, if it's no good, I'll take it back apart and figure out what we need to do to get it right. So same thing with the gap bed. You know, it contacts here, and there's no chips, there's no sealant sticking up. I don't want to go scraping it and trying to make it look all bright and shiny because that might actually make it out of true when I bolt it down. So let's get a light coat of oil on it. And I'm going to oil the whole thing just for rust prevention. This is a brand new chip brush, so it's nice and clean. This is where it's going to contact the ways. It might be a little more oil than I actually want, so I'm going to take a little bit of it off. Oil has thickness too. Here's the locating pin and the second one. I'm just going to snug them for now. Alright, well that one's, boy, it's starting to feel really close to what it was. There's no torque spec on these bolts, so these are M10 1.5, so a standard spec would be 70 Newton meters, which is pretty darn tight, but they were pretty darn tight, so that feels reasonable to me. So I know they're all at least adequately tight. I may adjust slightly. Boy, that's feeling really good. I'm going to go ahead and tighten this guy all the way down. See what we got here. I moved about 1/1000th. It's parallel, but it did come up. Now I'm checking the far side. This one was basically perfect before. Yeah, that one didn't budge. It changed a little bit when I changed direction, but it didn't change when I crossed the seam. That's what matters. And it stays right at 0 as I'm going along too. So that's good. Looking at this a little closer, it is less than 1/1000th. Boy. Yeah, that's just slightly right of the 0. and it's still not to the 1,000th mark. So that is, you know, maybe 6 or 7/10. It's not far from where it was. It might be where it was. Well, it moved, yeah, about 1/2,000th. So in the manual, what it says to do is use blocks of wood, I guess like tapping, and then to adjust how you tighten the bolts to get it to align as close as you can get it. This side just went straight back to perfect. This side, I mean, I'm really being picky here, but you want to get this as close as you can. So I've got a piece of pine here. It's not going to hurt those hardened ways. Let's give this a little tappy tap. Wow, that's less than half. Let me do a touch more and just see if I can get it a little bit better, and then I'll show you. All right, I would say it's moving a couple tenths at most, so we're crossing right there. Did you see it? Crossing right there. Coming back there. There you can see the far side does not budge when you cross that gap. Crossing it there. 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 All right, that is ready to use again. Yeah, I'm really impressed. They did the hand scraping underneath, and they've got the alignment pins. That was pretty easy. I have to say, good job, Grizzly. Long story short, I would not hesitate to take the gap bed out again and do a job with it if I wanted to. So what have I actually built here? This is 1-inch B7 alloy threaded rod. I've got 1-inch grade 8 nuts and then 1-inch structural washers. These are big, thick, heavy washers. Okay, so just like we did the welded one, you would assemble this around the track. The nice thing is, it's not a fixed length. Before I was having to do spacers and turn a pin down and have it, does it fit? I'd have to shorten it a little bit to get it to fit right. This, I can adjust the length. This is actually longer than the welded version was, but I can make it as short as I need it to be. Obviously your pin is going to be here, so you're going to have the bottle jack, and it just needs to sit between and have the pump down so that it doesn't get starved for oil. So I'm not sure if this strap is going to be something that I'm going to want or not, but it will at least help me manage the jack. I may make something more permanent after I've used it for a little while, if there's something that will make it better, but I want it to be flexible and fast, and I think these clamps will do that. Just like I did with the other pin, I'm going to be able to just jack it and generate 50 tons of force. You know, I can put a push pin here, bring this plate closer obviously, and then push the pin right through that hole. If I want to install a pin, I can put the pin actually here and have the track link up against that hole and just push the pin in. Pretty flexible system. $150 for the threaded rod. About $135 if I remember right for this 50-ton jack at Northern Tool. Now this B7 threaded rod is about almost twice as strong as regular all thread. And regular all thread, 1 inch, is probably not enough. If you're going to use regular all thread, you better go 1 1/4 inch, and you better talk to, well, do all this at your own risk, but talk to an engineer, because I think regular all thread, this would break. That looks like a pretty nice setup to me. These plates I didn't have to buy because a friend of mine was able to give them to me, but they wouldn't cost you that much. I mean, you ought to be able to get someone to cut out 2 14-inch circles in 1-inch plate for reasonably cheap. So, you know, maybe you're talking $350 total. Compared to any other pin press, This is worlds cheaper. It's 50 tons. It's very flexible. That means in the eyes of most farmers, this is the perfect pin press. Cheap and functional. So I know what you're thinking. You want to see me put this thing on a track and push a pin out. And I do too. But this video has gotten long enough, and I've got a lot of work to do before I'm going to be ready to push another pin out or install one. That's going to be in an upcoming video. Now, when is that video coming out? I don't know. With the holidays and getting these 2 videos this week, things have been kind of crazy. So it might not be on my typical schedule, but I will tell you this, I will do it as soon as I can. So happy holidays, everyone. Thanks for watching. We'll see you on the next one.